In the 15th question, we have 1 upon x power 4 minus 1. Okay, this is again supposed to be solved with, since this is a rational function, we'll use partial fractions. So we'll have to factorize the denominator first of all. Let's do it. Let's factorize the denominator. This x power 4 minus 1 can be factorized as this. X square plus 1 times x square minus 1. Since x power 4 is nothing but square of x square, right? And this further, this x square plus 1 cannot be factorized further. But this x square minus 1 can be written as x plus 1 times x minus 1. Right? This is what you can follow. Is that okay? Yes. That looks simple. Okay. So a similar thing, once again, when we have to write this as partial fractions. So 1 upon x square plus 1, x plus 1, x minus 1. This whole expression will be equal to what? This whole expression will be equal to, this quadratic will have ax plus b in the numerator, x square plus 1 in the denominator. Yes. Then you will have this x plus 1 in the denominator, which will have a simple constant c in the numerator. Then you will have x minus 1 in the denominator, a simple constant d in the numerator. That's what you will be looking at. Right? Okay. Once you have written this, then we can find the values of a, b, c and d by comparing the numerators, right? So therefore, numerator 1 is equal to what? So ax plus b, if we take the LCM, will be the product of these two, which is x square minus 1 plus c times what you'll get. Please observe for c, x square plus 1 times x minus 1 will come. X square plus 1, x minus 1 plus d will have x square plus 1 times x plus 1. If you observe this carefully, this is what you'll get, right? Taking the LCM over here, numerator will be this, and here the numerator is simply 1. And now we will compare. There are 4 unknowns over here, yes? And do you observe ax times x square will give me ax power 3, right? So first coefficient that we'll be looking forward to is coefficient of x power 3, which is 0 over here. 0 is equal to ax cube, which is a, and we have cx cube dx cube. So a plus c plus d is what I get over here. Is that okay? Yes. What else? Coefficient of x square. So let's focus on coefficient of x square, which is a 0 over here, will be equal to what? Coefficient of x square will be bx square. Yes. Is that all? Yes, that's what you'll get. There will be 4 terms. One will be x cube, the other will be bx square minus ax minus b, right? That's okay. So bx square is what I'll get. Here, cx square into this minus 1. So minus cx square was what I'll get. And will there be any other term of x square? Please observe, x power 3 minus x square plus x 9. That's the only term. And here also you'll get plus d. This is what you'll get, right? B minus c plus d as 0. What about coefficient of x? For coefficient of x, let's focus over here. This will be minus ax. And is there any other term? No, this is minus ax, right? So minus ax, that will be the coefficient of x. And here you'll have plus x into c. So plus c is what you'll have. There you'll have plus d. Right? Is that okay? Yes. What else? Constant term which is 1 will be equal to what? Here you'll have minus b as the constant. There you'll have minus c as the constant, and there you'll have plus d as the constant, right? This is what you'll have. Is that okay? Yes, that's okay. That looks okay. So what next? What next? Do you see that we can easily find c plus, we can eliminate from the first and third equation, we can eliminate a easily. From these two equations, we can eliminate b easily, and we'll get two relations between c and d. Yes. So let's use them. Adding these two will give me c plus d is equal to 0. And these two will give me b minus b gets cancelled, minus c minus d. And this actually becomes 2c plus 2d equal to 0, which is similar as same as c plus d equal to 0. This becomes minus 2c minus 2d is equal to 1. So that becomes minus c plus d is equal to 1 by 2. Okay. And adding these two together will give me 2d is equal to 1 by 2, or d is equal to 1 by 4. C, which is equal to minus of d, will be equal to minus 1 by 4. Once you have found c and d, do you observe that c plus d is equal to 0. So therefore a will also be 0 from the first equation, this one, right? And use this to get the value of b. B is equal to c minus d, this minus this. So minus 1 by 4 minus 1 by 4 will be minus 2 by 4, which is minus 1 by 2. So b is minus 1 by 2. This is what I'll be getting. That's the complete conversion into partial fractions. That's what you get. So A, B, C and D have been found. Therefore, integral I, which was integral of that, therefore this, and therefore this whole expression could be written as integral of ax plus b, which is 0 times x plus b, which is minus 1 by 2 upon x square plus 1. Then you have c upon x plus 1, which is minus 1 by 4 upon x plus 1 plus d, which is 1 by 4 over x minus 1 dx. This is what you have. Is that okay? Yes. What else? Once we have this particular thing clearly mentioned, then this integral is not difficult to find. 1 upon x square plus 1 will have integral as tan inverse x minus 1 by 4 log modulus x plus 1 plus 1 by 4 log modulus x minus 1 plus constant term, and yes, that's what you get, right? That's the final answer for this particular question, as you can see over here.